So, in the previous lecture, we have seen the formula for the Fourier series and some important concepts of beautiful integrals which help to solve the numerical equation. Now, in this video, we will see some numericals on Fourier series. So, as I already told you that for the Fourier series, we have two formulas. One when x belongs to and y, and other when x belongs to whole number. So, in this session, we will see when x belongs to whole number. Question. So now we have a first question where we have a value of fx is equal to x by 2, and we have given the interval where fx is defined, which is 0 to 2 pi, and also we have given that their time period is 2 pi. So it means after every 2 pi interval this value will repeat it. Okay. So for first question we have to sketch a graph of fx in the interval 0 to 4. So for that we have to first draw the graph. So for that we will scale it up by in the interval of 5, 0, 5, 2 pi, 3 pi and 4. Then what we have to do, uh, we have to first draw the graph on the given interval for 0 to 2 pi. So for the 0 to 2 pi, first we will calculate for the 0. For 0 the value of fx is 0. So when we put x is equal to 0 here, then the fx value is 0. So we will mark the point at 0. Okay, so it is 0, comma 0. Okay, so now for x is equal to 2 pi, so for x is equal to 2 pi, we will get the fx is equal to in place of x 2 pi, which will give you pi. Okay, so after that we have to point it out in these 2 points, and as you know, this is fx is equal to x by 2 will give you the straight line. Just we have to meet these 2 points and draw the straight line. So this will be your graph for 0 to 2 pi. Now we have to draw it for 0 to 4 pi. So it means our 2 pi to 4 pi region is remaining. But the function is periodic for 2 pi. Okay. So just what we have to do, we have to simply copy the 0 to 2 pi graph and simply paste it in the 2 pi to 4 pi region. So again, we have to draw that same straight line over 2 pi to 4 pi. So that's all for the graph. Okay. So now I already told you that there are two ways of asking the question. One is from graph to Fourier series or directly function to Fourier series. So if let's take an example that this graph is given to you and you have and we say that you have to find the Fourier series for that graph. So what we have to do, we have to just simply find the function fx for that given value. You can simply calculate it by the equation of line because we have given a line, and as you can see the graph is repeating itself after every 2 pi period. So you have to just simply take the 0 to 2 pi and calculate the function for this. So as it is given that coordinate for 0 point is 0, 0 and for 2 pi point is 2 pi, just simply take it as a x0, y0 as 0, 0 and x1, y1 is 2 pi, 5. Okay, so what the formula will say, y minus y0. So here y0 is 0 and then we have to find the slope m and x minus 0. So for m, we know what is m, y1 minus y0. So y1 is 5 and y0 is 0. So 5 minus 0 and x2 minus x1 minus x1. So 2 pi minus 0, which will get you pi by 2. After this will cancel out and give you the value of m as 1 by 2. So just simply replace it m value, y is equal to m value is 1 by 2 x. So from that we will get the value of y, which is you can replace it by fx, which is fx is equal to x, right? Okay. So y and fx is okay. So now if you got the fx value, then it is simple to calculate the Fourier series for you. So now let's calculate the Fourier series. So for Fourier series, what we have to do, we have to simply find the main three things, a0, an and b. So in the first step, we will solve the value for a0. So for the a0, the formula is 1 by pi on the given limit and fx 0. So what is the given limit for the fx is 0 to 2 pi, and we have the function value as fx is equal to x. So for the given limit, we will replace the value of fx, and then we will do the integration for x by 2, and whatever answer we got, we will just simply input the limits over it. Then after solving this, we can got the value of a naught as 5. And this is simple thing. Now what we have to do, we have to then calculate the value for a. So for an, we have a formula 1 by pi, 0 to 2 pi as the limit given, and fx cos n. So here fx is x by 2 and simply cos n. So now what we do, this is a constant 2 which we take outside of the integration, and then now we have to integrate only 1 by 2 pi, and this will just simply integrate 0 to 2 pi for the function x cos n. So for that, as you can see, the both functions are dependent on x, so we will use the partial integration. So what the partial integration says, we have to just put the first function as it is and do the integration of second function. So for the cos nx and nx, the integration is sin nx by n. Okay. Then we have to just simply put the minus sign, and then what we have to do, we have to differentiate x, which is 1, and then integration of cos nx, which is sin nx by n is constant, so we have taken outside, and then we have to again do the integration for sin. Okay, so now in the useful integral tricks, we told you if you have given a function sin nx over the integral of 0 to 2 pi, you can directly replace it with 0. So from here it is directly 0. So we have to only put the limit in the first part, which is x sin nx by n. So the limit is 0 to 2 pi. Now we have to take the upper limit and lower limit into 2. So what we got after that, we will got 2 pi sin 2n pi upon n minus, again after putting the value of x as 0, this whole term will become 0, and for that integral it is already seen that it is 0. Now what we have told, whenever we have a value for sin n pi came in our answer, then we have to directly replace it by 0 for any value of n which is integer. So as you can see, it is sin 2n pi, so we can directly replace it with 0. Simply this part is 0, this both parts is already 0, we can directly say that an value is 0. Okay. Now in the step 3, we have to calculate the value for bn. Okay. So for bn, we will use the same formula 1 by pi 0 to 2 pi fx sin nx is equal to 1 by pi. Just simply replace it, and again do the same thing, do the partial integration for x sin nx, and just simply when you solve this, you will again get this equation this integral for the cos nx. Again you have to replace it with 0 because cos nx integral over 0 to 2 pi is 0. Okay. Then just simply whatever the integral answer you got in the first part, you have to put the limit over it like 0 to 2 pi, and then you will simply got the answer as minus 1 by n cos 2n pi by n. Okay. So for that, what we have to do, I already told you that cos n pi is equal to minus 1 power n, and as you can see here 2n, it means it is always even. So if n is even, then we can directly replace it with 1. Okay. So here you can directly replace cos 2n pi with 1. So we will get bn is equal to minus 1 by 1, since 2n is even. Okay. Now we have got the value for a naught, an and bn. Now we have to just simply put it in the equation of fx. So we have a naught as 5. So in place of a naught, we will replace it by pi by 2. As an is 0, this whole term becomes 0. And just we have to focus on bn sin nx. So bn value is 1 by n. So what fx we will got pi by 2 plus summation of n is equal to 1 to infinite minus 1 by n sin n. So we have to now expand this summation sign. So which is fx is equal to pi by 2, taken minus as a common, and just simply put n is equal to 1. So sin 1 x by 1, which is sin x, plus Sin for n is equal to 2, sin 2x by 2 plus sin 3x by 3 and so on. So this is our desired Fourier series for the fx is equal to x by 2. Now let's take another example where we have a function fx which is partially distributed. So here fx is equal to x which is defined over 0 to pi interval, and we have fx is equal to pi for the interval over pi to 2 pi. Just similar to previous question, it has a period of 2 pi and we have to draw the graph for minus 2 pi to 2 pi. So what we do first, we draw the graph for 0 to 2 pi part, which is this part. So for that, as you can see, fx is equal to x for 0 to pi region. So we can just simply put the straight line over 0 to pi region, and then what we have to do, we have to draw the straight line for pi from pi to 2 pi. So this is a horizontal line we have to draw for pi to 2 pi, and its value is pi. Okay. So as you can see, so we have to draw the graph from minus 2 pi to 2 pi, and we have covered the 0 to 2 pi interval. So it is periodic for the 2 pi interval. So just we have copy pasted for the minus 2 pi to 0 interval, and then we can get the resulted graph. Now for that we have to find the Fourier series. So same as the previous one, we have to calculate a0, an and bn. But here what we have to remember that whenever we do integration of a0, we don't directly put 0 to 2 pi. We also have to break that formula for 0 to pi and pi to 2 pi and use the function which is defined over that limit. Okay. So for fx which is over 0 to pi, the value is x. So we have to do 1 by pi 0 to pi x dx. And for the pi to 2 pi, you have to use fx as pi. So we will write 1 upon pi, pi to 2 pi, pi. Now just simply integrate both the integration and put the value of their limit, and finally we will got the answer of a0 as 3 pi by. Now same for we have to do for an. So for an, we will break it into 0 to pi with x cos nx, and same x cos n pi with pi to 2 pi limit. Now as I already told you, this is not a constant here. This is not for the cos n pi. But we can now directly replace it with 0 because their limits are from pi to 2 pi. So the difference is only of pi. So 2 pi minus pi is pi. So you cannot directly use and state that its value is 0. Its value can be anything. So now what we have to do is to just simply integrate it. First integration is done by the partial integration by part, and second one is we have to directly do the integration, and after integration we will got these values over here. Then what we have to do, we have to directly put, like here we got the sin 2 and pi, sin n pi, so these values directly 0. Similar here we got sin n pi, this is 0 and this is already 0, and we have to put the limit over this cos n pi by n. When we put the value limit over there, we will got the answer as cos n pi by n square minus cos 0 by n. As you know that cos 0 value is 1 and cos n pi value is minus 1 power n. As final, after taking the n square as common, we will get the equation as minus 1 by n square pi minus 1 power n minus 2. Now what we have to do, we have to just do one thing. We have to take n as odd and n as even. So I told you for the minus 1 power n, whenever the n is odd, you have to replace the value it's by minus 1, and when n is even, you have to do with 1. Okay. So when we put n as odd, then it is minus 1 and mentioned which will combine to make minus 2. So for n is equal to odd, an value is minus 2 by n square pi. And for 1, this value will become 1 and this is minus 1, which will cancel it out and give the resultant answer as 0. So for n is even, an is value is 0. Now same, we have to calculate the value for bn after the whole integration. Um, we got the limit of bn is minus 1 by n. Okay. Now what we have to do, we have to just simply put this value in f. Okay. So we have a function f and we have a value a naught is 3 pi by 2. So just simply put fx in a naught 3 pi by 2, and also we have a naught by 2 which is some a 3 pi by 4. Okay. Now we have to put the value of an. So an value for n even it is 0, for n odd it is minus 2 by n square pi. So we have taken the minus 2 by pi as common. So minus 2 by pi is common. Then what we have remaining, cos n pi by n. And here the value for n are odd. So what we'll do, we will firstly put the n is equal to 1. So for n1 it is cos x upon 1. Now we have to put directly n is equal to 3. So cos 3x by 3 square, then 5 cos 5x by 5, and so on. Now same with the bn. Here we have taken the minus sign as common outside. Then we have the value of sin n pi by n, and we have to just open the summation sign for each value of n, because here nothing n is defined, it is defined over all values of n. For n is equal to 1, we got sin x, for n value 2 sin 2x by 2, for 3 sin 3x by 3, and so on. So this is the overall Fourier series for the function which is different. I think you all cleared about this concept. So now in the next section we will see some questions on the interval of minus pi to pi. Okay. So thank you so much. We will meet in the next lecture.